Now a kite is a quadrilateral that has two pairs of consecutive congruent sides. So we've got AB and BC here, and AD and CD that are going to be congruent to each other. So I'm going to write that out so I just remember. AB and BC are congruent, and AD and CD. All right, but guess what? The opposite sides are not going to be congruent. So unlike a parallelogram, AB and CD they're not congruent, and we see that by our markings. All right, so now we've got 3 different theorems. So if a quadrilateral is a kite, let's mark it up. This is our kite part right here. We've got our hypothesis, or our given. So if it is a kite, then its diagonals are perpendicular. Right? So what that means is that BD is going to intersect AC at 90 degrees. All right? So we can even put that in right here, that AC is perpendicular to BD. That's it. It's just perpendicular. And by the way, super big hint that you're going to need. Okay, this creates 4 right triangles. Oops. If you don't see it, I'm going to show you really quickly. All right, you get triangle ABD. Is that right? No, oops. Sorry. You're going to get this one right here. You're going to get this one right here. You're going to get this one right here. And you're going to get this one right here. All right? So you get 4 right triangles. That'll be helpful for you when you have to use the Pythagorean theorem. Hint, hint. All right, so we're not going to go to the next one. We're going to come back to it. There's a theory behind my madness. I promise there is a reasoning for it. So now if a quadrilateral is a kite and, oops, you don't need this part here. So we're going to put in if a quadrilateral is a kite. Let's mark up our kite. Consecutive sides are congruent, right? Then, exactly 1 pair of the opposite angles are going to be congruent. So, what that means is that if we have 1 pair, if we just have a quadrilateral, ABCD is a kite, and we know that BC and BA are congruent, pretty much, and that AD and CD are congruent, which are what we need for a kite, the consecutive sides to be congruent, by the way, then you can state that the angles are congruent. So angle A is going to be congruent to angle C. This one right here. However, angle B will not be congruent to angle D. You do need to have one set of opposite angles that are non-congruent. All right, it's only one pair of opposite angles that are congruent. Now, that's part of our theorem. It's part of being a kite. So let's really quickly go ahead and adjust this right here. Oops, let's use a different color. And put that in. You need to know that about a kite. All right, now knowing that, let's do our second theorem. If a quadrilateral is a kite, all right, here it is again. So let's label it up. If a quadrilateral is a kite, we've got two sets of consecutive congruent sides, and don't forget what we just put down, exactly one set of opposite angles that are congruent. And by the way, if you're like, well, how did this happen? How did that third theorem happen? Check out this triangle right here from our first theorem because of our right triangles and everything. Those two triangles right here, triangle BCD and ABD, those are side, side, side congruencies, which means because those two triangles are congruent, that means those angles are going to be congruent. And you can use that to help you create this next theorem that says it's one diagonal then bisects these non-congruent angles. So pretty much, if you've got angle B right here, all right, and it's got, I don't know, we're going to put two lines on it right now, and you drop your diagonal from it, all right, then what you get is that angle ABD is going to be congruent to angle CBD. And I'm sorry, I don't think you have enough room in those blanks right there. So if you want to write it here, you can. Angle ABD is going to be congruent to angle CBD. But also, that bottom congruent angle also gets split. And angle ABD is going to be congruent to angle CBD. And again, this comes because we've got two congruent triangles creating this. All right, two big triangles. All right, so this all stuff goes here. All right, now that we have these theorems, we can work on some examples. So find the measure of each numbered angle. Well, the first thing that we're going to use is that angle 1 right here is perpendicular. And we know that from our theorem that our diagonals are congruent. The diagonals are perpendicular. Then we're going to use that second theorem, the last one that we just spoke about, that this diagonal cuts this opposite angle into two congruent pieces and bisects it, which means that the measure of angle 2 is going to equal 32 degrees. And I'm writing down that it's an angle bisector for my non-congruent angles. All right, and our last one, this is just going to be using our triangle sum theorem. And you're like, what? Again? Yep, again, because check this triangle out. You've got 90 degrees here and 32 here. So you need to figure out what angle 3 is. Well, you can do that one of two ways, or two ways. The first one being you do 180 minus 90, And then that gets you 90, and then subtract the 32 from it, and that gets you 58 degrees. So that's using the triangle sum theorem. Well, guess what? You could have also used that right triangle corollary. That means that because it's a right triangle, you know the other two angles are going to add up to be 90. You would only have had to done this work right there. Whatever floats your boat, though. If you wanted to subtract 90 a little bit more, go for it. All right, let's do this next one. Find HE if HRSE is a kite. Well, if HRSE is a kite, we know, and because we're working with our sides, we know that this is going to be 90 degrees. Okay, HRSE. And we're looking for HE. So we're looking at this triangle here, because remember I gave you this hint that it creates 4 right triangles? Well, that triangle right there, it's a right triangle. In fact, it looks like this. Let me move this over really quickly so you can see. We've got H, all right, and this is E right here. We know this is 20, and we know this one is 12. Guess what? You're going to use A squared plus B squared equals C squared. In this case, you're going to be looking for your hypotenuse, which is across from the right angle right here. And so that's going to be your C. The rest you can plug in, and we get, I'm going to put in 20 squared first because just what I see first, is equal to C squared. It doesn't matter if you put 12 or 20 first. As long as both of the legs are in there, it don't matter. So we've got 400 plus 144 is equal to C squared. 544 is equal to C squared. Well, we're not looking for C squared, we're looking for C. So we're going to take the square root, which is the inverse action of a squared, and we're going to know that C is equal to the square root of 544. Well, we can't leave it like that right now, but if it were to ever ask you for an exact answer, you would leave it in a radical form and simplify that radical. And if it asks you for a decimal form, you type it in, and you're going to get that HE is approximately equal to 23 point, let's do the hundredths, 32. If it asks you for the hundredths, you do the hundredths. If it asks you for the tenths, you do the tenths. All right, let's do this next one. We're going to find the measure of angle ABC and the measure of angle CDA if ABCD is a kite. Well, we know it's a quadrilateral, so it's going to end up being 360 degrees. What we also know from our last theorem is that angle ABC is going to be congruent to angle CDA or ADC. And because these two are congruent, we can just do our math easy. So really quickly, what we're going to do is we're going to subtract both of these from 360. Gets me 290 minus 36. That gets me 254. Well, 254 is the sum of both of these. So 254 divided by 2 is going to get me the measure of both angle ABC and CDA. And that gets me 127 degrees. There you have it. Thanks for watching.